Hi, welcome back to HOSTBOX channel and back to the tutorial for computer networks and continuation. Today we are going to see the topic called cycle redundancy check for error detection and correction. The previous session I explained about single bit error with Hamming code distance. So please kindly support the channel and check the playlist when you have doubts. This is a tutorial definitely helpful for whoever want to crack the exam, GATE, UGC, university or any kind of exams and whoever want to learn the basics of networks properly. Let's go for today. So cycle redundancy check is one of the mechanism or you can say technique used to determine the error. Here steps used in CRC for error detection at center side. So we have to check it out both sides, center side and receiver side. So steps involved here. First step is find the length of the divisor L. Then append L-1 bits to the original message and perform binary division operation and remainder of the division become the CRC. That is a cyclic redundancy check. An example. Let's take the example. Suppose we have the original data is called 11100 and the device is 1001. Now how to apply CRC method and do the transmission, data transmission successfully. What will happen? The center side and receiver side. So here CRC generator will be there. Here a CRC generator generally uses a modulo 2 division. And before going this example and explanation here about binary division operation. So when I go for the binary division operation, we have to take care of the XOR operation. We have to perform the exclusive XOR operation here. So in the previous session also I told about something about the XOR operation. That means so exclusive XOR operation. So if different outputs, if 0 0 is there, output is 0. If different inputs, output will be 1, and if both are 1, if both inputs are 1, the output becomes 0. So whenever like this condition, we should not bother about it. So let's cover session today how to solve this problem. Here remember, whenever length of the bits divisor, that is suppose the length of the divisor is 5, that is L-1. Here to add 4, that means appending or joining the 4 bits, 4 zeros with the actual bit. So this is a message, it's a data block where this is a message, that is what 11100 the message. We are going to do the CRC for transmission. Let's see the diagram, you get the idea. Here first, what is the division here? Remember, the division is the divisor is the common for both center and the receiver. Let's go for here. So here first I am going to consider the 11100. As you know, the L value is what? That is 4. So L value is 4. So we have to add the L-1, that is 3 bits, 3 zeros we have to append with the original message. 3 bits. How many bits? 3 bits we are going to append with the actual bit here. So already 11100 is there. I am adding 000 here. 000 adding here. Then this is the quotient. You know, this is the quotient. This is the divisor. So let's perform the XOR operation one by one. We will start the division operation as well as the perform the XOR operation here. So first, how many? What is the bit here? 11100 is there. I am keeping the 1001 and I am going to check it out with the divisor. So here we take the XOR operation. So 01 answer is 1 and 10 again 1 and 10 again 1 and 11 answer is 0. You don't bother with it. Okay, whenever 0 comes, you should ignore it, no problem. Whenever 0 comes, we can ignore it, no issue. Okay, now what happened? One time over, one time division. Next time taking the bit of 0 here. Already 11100 I am taking 000. So again I am going to divisible by 1001. So again I am playing the XOR operation, exclusive XOR operation. So 01 answer is 1 and 10 answer is 1, 10 answer is 1 and 110. Again we can ignore it. So now 111 is the answer. Again I take the next bit, that is 0. So again I am keeping by 1001 the divisor. Then again you will get the answer of 111. Again we will take the another bit called 0 and again divisible 1001. Take the XOR operation, exclusive XOR operation here. Here we are coming. here. So how do you get? So you will get 0 1 1 and 1 0 1 and 1 0 1. Again ignore the 1 1 0. So triple 1 and last bit is 0. Now we again divisible 1. See the question carefully. Question we are getting 1 1 1 1 1 so on. So fifth time doing. So how what's the answer now? Again I will get the answer of 1 1 1. So this is the CRC remainder. What I am getting finally, that is the center side is the CRC remainder. See, we can stop the center receiver now. So now what is the actual data transmitted here? The data transmitted is 11100 with the CRC remainder, that is 111. Sorry, 111 here. Okay, so already what is the message here? 11100. The original data transmitted is what we can append the CRC here. So the 11100 followed by 111. This is happening in the CRC generator server side. Now the question is, what will happen on the receiver side? How the receiver also receives the same data. Now how the receiver how whether the data is corrected or not? Data is corrected, is wrong or not? So accepted or not? Let's see the receiver side. So before going to remove this point, the function of the CRC checker is similar to the CRC generator. This is happening in the receiver side. Based on the protocol, when the string is just now I told 11100 is received at the receiving end, then the CRC checker perform the modulo 2 of a division. So it will perform the modulo 2 division. Very important point. Modulo 2 division. Then a string is divisible by the same divisor. Just now I told you the divisor is common for both sender and receiver. Remember, whenever the receiver side is the remainder 0 0 come means the data is accepted, that means data is correct, otherwise not. If different outputs come 0 1 or 1 0 something, the data is wrong. Like that, the data transmission is wrong, we have to try the retransmission with the help of CRC. So in this case, the CRC checker generates the remainder of 0, therefore the data is accepted. Let's see the explanation. So whenever the CRC checker generates the remainder of 0, that is the data is accepted. So this is a small example for understanding the CRC. Let's see, continue here, take the division. So now what are the information there? I am going to apply the modulo 2 division. So that is what I have to apply the again exclusive XOR operation only. In the binary division I have to do the XOR operation only. So here same. So I am going to take the first 11100 is there. First I will take the 4 digits. I divisible by only one time. So I am writing 1 here. That is 1001. So take the binary division answer here. That is, this is highlighter, right? So here, here what will happen? So same we are writing the exclusive operation here. So here 0 1 1 again 101 again 101 1 comes 0, you can ignore it. Then take the next bit, so that is 0. Again divisible 1001. Now again you will get the result of 011 and 101 and here 101 and here ignore it 1. So next bit is 1. By default I am taking the next bit for operation. So now we will get the, now we have digits 1111 and again how many times disable? Only one time. So I am writing 1 in the question and continue the 1001. Again here I will get the answer of 110, then 101 101 and 101 110, ignore it. Okay, so I will get the answer of here 11001 and again divisible 1. So write the question 1 and 1001 divisible. So again we will get the answer of 0110 001 because we are applying exclusive XOR operation. Taken 101 and 110, ignore it. So we will get the answer of 100 here and last bit is 1. Now we will complete the step here 1001 again divisible 1001. So automatically we will get whenever the different outputs, whenever the same outputs, the answer will be 0 in the exclusive. So all become 0 now. Carefully listen. So 1001 is there, again 100 now. So answer is the remainder is 0. So now the conclusion is what? The receiver Deduct the error with the help of CRC successfully. Here data is accepted. That is, there is no error in the above transmission. Whatever the original data transmitted here, that is, here I am showing now. Here 111. So 111, 00, 111. What are the data received? What are the messages passed by the sender? It received by the receiver successfully. So like that you can practice with the polynomial expression also. So simple and easy. And if you have any queries or suggestions, please kindly communicate with the social media. And thanks for watching. Please like, share, comment, press bell icon for more updates. Thank you.